All right, guys, I'm gonna go over RC4, which is the main thing. Is quadratic. Let me get my highlighter real quick. RC4 is over. Oops. Ooh. Sorry. Quadratic functions and equations. Oops. Again. Sorry. And you have to be able to. Yeah, there it goes. Functions and equations. Writing, solving quadratic equations. Okay. This was the last test we just took on the secure site. So far, you can look at your table, look at your percent score, and if your percent score was 75 or greater, you're above target. If it's between 60 and 74, near target, and below 59, under target. So one of the key things for this section is making sure you know the different forms. Okay, this is an example of standard form. In standard form, all forms, it's y equals, and we want it to equal to 0. So we want to end up substituting 0 for the y here. But we need to know the parts. So in standard form, you need to know your a, your b, your c. Okay, a is the coefficient of the x squared, b is in front of the x, the coefficient of x, and c is your constant. Vertex form, this is where y equals a, parentheses x minus h, parentheses squared plus k. So in vertex form, the keyword vertex, that is your h and k. Okay, and we want to plug it in. Remember, whenever we take the h out, we do the opposite, or if we plug it in, we do the opposite. And then factor form, we've mentioned factor form, we mentioned it in factoring, but we haven't really done some problem solving with that. So we should have two groupings, two parentheses, and remember what's inside the parentheses, when we take it out, that is our solution. So I know it says minus m and minus n mean negative, but when I take it out, they're both positive. Okay. All right, so these are 3 forms you're going to have to problem solve or use or understand to get to your solutions. Now, label our axis of symmetry, our vertex, our y-intercept, our root. So at this point, majority of our first test over RC was making sure you knew the key attributes of a quadratic function, a parabola. So our axis of symmetry, guys, remember a parabola, this has the U shape right here. Our axis of symmetry is a line, a reflection line that goes through the middle of the parabola, and it should go through that turning point, which has a special name here. So this axis of symmetry is always a vertical line. There it is right there. Hopefully you can see that vertical line. I don't think it's showing, but it's going through this value right here. Let me get my pen. On the x-axis, it's going to that -1 right there. Okay, so that means that our axis of symmetry is x equals a -1. Okay, so we want you to label it on the graph and be able to fill in the information in the table. All right, now our vertex, all right, our vertex is our max or min. That's another way to kind of think of it. And it is the highest or lowest point of the graph. So down here, I'm pointing at that point right there. That's our vertex, which means that order pair is -1, -8. Okay. Now the other thing they want you to be able to identify is your y-intercept. We've done that plenty of times. Oops, that's not what we need right there. Sorry. So that is the point where it touches the y-axis right there. That point is 1 unit away from the axis of symmetry. We need that for something later. It's coming up right after we answer our max, min, and x-intercepts. So that point is the order pair 0, -6. All right, so in this parabola that opens up, whenever it opens up, it's going to have a minimum, a low point, versus when it opens down. And when I'm talking about opening down, I'm talking about the parabola looks like that. Okay, maybe not to scale, but that is a negative parabola, that would have a max. All right, so because we have a minimum here, we have to find the value at the y, how low it goes, which is right here to -8. So this says I'm going to circle minimum, and that minimum value is -8. It's not the order pair of the vertex, it's just the y coordinate. All right, so you can add that to your graph as well. You want to be able to label it on the graph and in the table. I said that earlier. Now, your x-intercepts. Most of y'all are doing great jobs of seeing. Y'all see when it touches x, when it crosses x. It's these 2 points right here, and we need the values there. Okay, so it happens at a -3 and 1. So we either put the order pair okay? Or we can put the bracket. So our x-intercepts are -3, 0, or 1, 0. Okay, so you can add that as well. Now, another thing you need to know, these terms are interchangeable. When they ask for an x-intercept, they might say the word x-intercept, but they also call that intercept the zero or the solution, or we also call it, let me see, it'll pop up. It's missing. Where are you at? There we go. The root. Okay. So understand those three words are interchangeable. They all mean the same thing. And then our point, that's what this little arrow here pointing 1 unit from the axis of symmetry. Well, then the other point that we see is also 1 unit from the axis of symmetry is this point right here, which is at -2, -6. Okay, now as for our domain, because our parabola in this picture right here has a double arrow, meaning it's going to keep going on and on and on forever, our domain is going to be our real numbers. Now the range is determined or written based on if you have our max or min. So remember, if we open down like that, a parabola is going to have a max. I probably should move that over just a little bit. There we go. Come on. So let me. There we go. There we go. So if it has a max, then it's pointing down. That means this would be less than or equal to that max. Now, if I have a minimum, so that means the parabola is pointing up. Okay, we have a minimum. Then that range would be y is greater than or equal to whatever that minimum is. So in our problem, we have a minimum at a -8. So our range, let's answer here, is y is greater than or equal to -8. Okay. All right, so make sure we can identify these parts on the graph. Make sure we can write the equation of the axis of symmetry, it's a vertical line. All right, and we can come to our domain and range, especially the range. All right, so now our star-like questions. So which of the following is correctly shown in transformation of a parabola from the quadratic parent function? So this starting off right here is the parent function. And if we look, all of our answer choice are in vertex form. Remember, vertex form is when we have a parentheses x minus h, close the parentheses, squared, and then plus k. So when they're asking for the transformation of the quadratic parent, they're referring to the graph that they gave us here, this parabola in black. Our parent function is, I'm going to just kind of sketch that. Our parent function, I have to go a little bit higher, sorry. Our parent function comes down like such. Sorry, it's not accurate in the curves here. So I need to fix this. So, sorry, it's the back sketch. There we go. There's our parent function. So what they're asking is, if this is the parent, how did it transform to the black? Well, if I just go based on the vertex alone, it shifts over 1 unit, that's unit to the left, and then it came down 8. So if I'm looking at left 1 and then down 8, remember left, even though on the number line it's going to the left is negative, but we have to do the opposite. So this would be x plus 1 parentheses squared down 8. That would end up being minus 8. And so all I really need to identify now is our a. That's this coefficient in front of the parentheses. And this is going to easy for me to see because they're all the same in the answer choices. So that means this coefficient, the a, is 2. And it makes sense that it is 2 a's. One, I don't know if you can tell, but I know my parabola of the parent is kind of off. But this right here kind of got skinnier. Okay. And if we weren't sure, let's say we weren't sure to compare with it. Let's say you could use your calculator basically to problem solve. Let me show you. So in a situation like this, because it's in function notation, I would use the decimals calculator. Let me see if I have it up. Hold on, let's see. All right, so here is the decimals calculator. And one thing it does let us do, and even on the secure network, is you can put it in function notation. So I'm just gonna open up my keyboard here. We're gonna go F and then parentheses X. We're gonna close the parentheses and make it equal to our parent function, which was x squared. So right now, because I just put x, it's gonna make it a line. I need to give it an exponent of 2. So I can go to the keyboard down here, add my exponent, and now I have my parabola. Okay. Now, if I go to just click on the next line and use the answer choices that are given, which is right here. If I type it the way it's written in function notation, it will show the transformation for me. If I go back to our decimals calculator and we go, basically, let me get my keyboard up here. We have 2, and then we have F, parentheses, X plus 1. First one was minus 1. So let me do that first. And then close the parentheses, and then we had minus 8. So look, I don't know if you saw it here, but basically, let me zoom out. Here it is. So here's the parent, and then it moved over and then came down. This is the new function. So that doesn't match the transformation of the black one that we see. So what I want to do is I want to change this. Let's look to answer choice. Answer choice B actually had +1 and then -8. Oh, I gotta put the 1. And if I look here, there went over 1 like that and then came down 8, and it matches the black. Now the reason why I like the decimals with function notation, 1, you can just type it the way you read it, and then 2, you can move, you can zoom in and zoom out a little bit better, I think, on the decimals calculator. If I need to see a point, I can hover over the actual graph, find a point and click, and it'll keep it there. That's 0, 0. There's another point, there's a decimal point. There's my y-intercept, there's my vertex. So you can kind of literally click on the points and it'll show up. So let's get to where we were. So I could have also just looked at my vertex, which was up here, which we knew about right there, and then plugged it in. So this was B, right? Now what they want us to do on number 2 is to convert the equation of the parabola that we have, which is in standard form right here, into standard form. Into standard form. So this is vertex form. I just realized I forgot to mention something here. I know we found the A's just because they were all the same. You can work backwards and solve for A. Like I could have put A here, plug in another point, my y-intercept, and for my x and my y, and then plug in, but we're not going to do that. I wanted to show you something. So if you put your pencil on the vertex going to the y-intercept, this is a rise of 2 and a run of 1. So this is up 2 over 1, so 2. Okay, if I had 2 over 1, that would just be the same as 2, or up 2 to the left 1. So because the slope between the 2 points here is 2, then that's why our A, our coefficient in front of the parentheses, is also 2. So what we're going to do is take the vertex form, which is the 2 parentheses x plus 1, close the parentheses square, minus 8. And I'm going to move this down just slightly. Okay, and we're going to convert this into standard form, as the question says. Remember, standard form is when we have ax squared plus bx plus c. Okay. So in order to do that, you have to remember your little steps, which is you have to expand your binomial square. You have to use your FOIL method. You have to distribute. And you have to combine like terms at the very end. So first thing I'm doing is I'm expanding my binomial square. So I keep the 2 in front, and I write 2 factors, because that's what that exponent is, of x plus 1. So I have x plus 1, one factor, x plus 1, the second factor, then minus 8. Then we're going to use our FOIL method, first, outer, inner, last. We keep the 2 in front. The first terms are the x times the x, which is x squared. The outer term is x times 1, which is 1x, or just x. Inner is right here, this 1 times x, so that's another x. And the last terms are 1 times 1, which is 1, okay? Minus 8. Now, I can combine these like terms, or I can just go straight to D, which is distribute. So I'm going to just distribute first to each term inside the parentheses. So 2x squared plus 2x plus another 2x plus 2, and then minus 8. And then the last thing I'm going to do is combine my like terms. My like x's are right here. My like constants are right there. So we end up with 2x squared plus 4x minus 6. And then what they could ask, kind of got erased here at the bottom, what they could ask is understanding that this equation is the standard form. You would write like y equals to 2x squared plus 4x minus 6. And then from that, because that's your standard form, they would want you to identify the A, the B, and your C. That should be in green, sorry. Okay, so in my standard form, which we had up here, the A is in front of the x squared, the B is in front of the x, and the C is your constant. So if I look at my equation I have, this would be my A. So A equals 2. This would be my B equals 4. And my C equals, my C equals a negative 6. So make sure you can identify those parts. This is because most likely this could be a multiple choice question or an open-ended where they ask you to type in the A, B, and C. Okay. All right, so from there, we're now going to have you analyze some graphs to come up with the equation. So they want you to give the solution, the factor form, and the standard form of the parabola shown. So remember your solution, aka also known as the root or the 0, okay? It is where it touches the x-axis, the parabola, the graph. So our solutions here, x equals a negative 1 and x equals 3. Or I can put it in a bracket notation of negative 1 comma 3. Now, for factor form, you have to remember to do the opposite of these values for x. This would be x plus 1 and x minus 3. Okay, this is our factor form. And to get it into standard form, which is standard form is the ax squared plus bx plus c, we are going to have to use our FOIL first of those two binomials. There's nothing to expand, so normally I would do expand, FOIL, distribute, combine like terms, but we have no expanding. We just go straight to the FOIL. First times first, so I'm just going to write it down here. This would give me x squared. Outer would be minus 3x. That's the x times is negative 3. Then we have plus x and then minus 3. All right, so we're going to combine the like terms here. And we get x squared minus 2x minus 3. So this is the standard form. And what we need to know from that form is the A, the B, and the C. Oops, sorry. So the A is the coefficient of the x squared. That would be like an invisible one there. So A equals 1. B, the coefficient of the x, that's a negative 2. And your C is a negative 3. Okay. All right, so let's try this one. I want you to see if you can come with the solutions, the factor formulae. So I'm just going to pause the video, give you time, you pause for yourself, and then let's check your answer. Okay, so you should have your root, so your solutions are -3 and -1. I forgot the sign on this bracket formation right here, so that's the -1. And then we do the opposite for factor form, so +3 and +1. And then for your standard form, remember that's when you're doing your FOIL again. So this would be x squared plus x plus 3x plus 1, and this simplifies as x squared plus 4x plus 3. Now, there's a small little error here. One is this graph is opening down, which makes it negative, which means there is an invisible -1 in front of these two groupings that we did the FOIL from. So I have to distribute a -1 here to simplify this correctly. So this would be a -x squared minus 4x minus 3. Okay. And then in here, I could see my A, my B, my C. My A would be the -1, B -4, and C -3. So negative sign, sorry. Okay. Now, the other thing you have to do is understanding transformations. We did this already with RC3, I believe. Just kind of remember outside the parentheses, we talked about that. Plus or minus, if it's plus, it's up. If it's minus, it's down. If it's inside the parentheses, you have to do the opposite. So it's inside this grouping right here. So it's plus, then that means it's actually to the left. And when it's negative, it's actually to the right. Okay. And then the coefficient of A in front of the parentheses, if it's greater than 1, we're looking at some type of stretch, which means it gets narrower. And then if it's between 0 and 1, we're looking at some type of shrink, which means it gets wider. Now, if the A is inside the parentheses and it's the coefficient of X, and it's greater than 1, it is a shrink. If it's between 0 and 1, it's a horizontal stretch. And then you do kind of need to remember, you see a negative sign, that's going to be reflected over the x-axis. So the outside the parentheses curve versus inside would be reflected over the y-axis. All right, so there's multiple ways we could do this, but if ever you're not sure, always compare, always use your calculator. So they want you to describe the transformation of f to g. So right off the bat, f of x equals x squared. That's the parent, okay? So this is the original. You want to put original. And then g sub x, this is the new function. Okay, so basically I want to look at how it changed. Basically I see this negative side, and I see the other change is this +3. So I look, I know the negative sign is going to reflect how is the reflection. So this is reflected over the x-axis. And then that +3 means it's going to go up 3 units. Okay. So I can just figure out the changes comparing the original, the parent function, to the new function. And if I look on this new function, I now have a coefficient of 2 outside the parentheses. Anything greater than 1 means it's going to be a vertical stretch. And then if I look, I have +3 inside the parentheses. 3 is usually positive, but if it's inside the parentheses, you do the opposite. So this was a vertical, I'm just going to abbreviate that, vertical stretch. Or you can say it got narrow, it was narrower, or some people say skinny. Okay. And then the other thing we have to say is that it went to the left 3 units. So comparing the graphs might help you get to your answers. And I'm going to show you on the regular TI, because we have f of x and g sub x. So I could go to my calculator. I got to turn mine on, obviously. And then we can put the parent function in as my y1. So I would type that in into the y equals and look at that graph, and then we can put g sub x into y2. So let me close this out. So parent function y equals x squared, that's y1, and then g sub x, we're going to 2 parentheses x plus 3 close the parentheses square. Okay, and then we can just graph them. There's the parent. So I can physically see that it moved to the left, and also it got narrower. The blue is wider than the red, so that can help you as well. And then if, let's say, the function notation is confusing, then you could always, I'm going to delete these. I probably should have kept that one. We can always go back and type in our parent function using function notation. Sorry, let me get that. So f parentheses, oops, it's not even there, sorry. F parentheses x, close the parentheses, equal, and then we're going to put x squared. Now you could also, oh, it's not going to be there. You can get to your exponents, you hit the keypad and then x squared. So there's the parent, okay? And then in the second line, we're going to do our g sub x. So I can use function notation, which is g parentheses x, close the parentheses, equals, we have 2 parentheses x plus 3 plus 3. We're going to close it and we're going to square. So I need to look at the x. I'm going to square that. Look, right there off the bat, I can see the black parabola is my parent, my red is a new, and I can physically see that it moved over. It looks like 3 units. So this is 1, 2, 3, yeah. And then I can compare that. And if you're not too sure, you could always like hover your mouse here, and you can see one's wider than the other. This one is getting a little narrower or skinnier. So you can use your calculator to help you problem solve. So on this last one, I'm hoping you can see that the change, the 1/2, is inside the parentheses. And when it's inside the parentheses right here, and we have a fraction, this means we would have a horizontal if it's greater than 1, compression or shrink. Oh, it's not greater than 1, sorry. It's stretched. I'm sorry, I misread it. The 1/2 is a fraction. So that means it's right here. So horizontal stretch, sorry. I apologize. Now, we can use the calculator to check. I'm going to go back to my decimals calculator. I'm going to change my g sub x here. So that we have parentheses, and inside the parentheses, the 1/2. So 1, and then don't see if I get my keyboard right here. We do slash, that would make C. I did a slash and I got the fraction box. Then we do 2, and then we're going to arrow to the right. We're going to put our x. Then we're going to also arrow to the right again. And we're going to put our exponent right there. And you can physically see how wider it got, right? Okay, so this was a horizontal stretch, like it's pulling out to the horizontal. All right, so then the last things we have to cover are, oops, sorry. It's here, but it's up here. There we go. It's solving ways to solve. Now, a couple things you need to remember is that the equation must equal 0 to solve, okay? Equation must equal 0. To solve. All right. So I'm going to go 3 different ways here. Using your calculator. Again, we need the equation equal to 0. So here it's equal to 30, so we're going to have to subtract 30. 30 cancel, and that becomes a 0 on the right side. So when I rewrite this, I have x plus 2 parentheses squared minus 34 equals 0. So now I can put this in my calculator using y1 as x plus 2 parentheses squared minus 34. And then my y2, I want that to be 0. So if you go to your calculator, because I want to use a calculator, I need to find the x-intercepts. So I'm going to go y equals, I'm going to clear this out, and we're putting parentheses x plus 2, those are parentheses squared, and then minus 34. And then here, I'm going to clear this out and make this 0. And we're going to graph it. Look at the graph. I know I don't see all of it where it turns, but what I really need is just see where does it touch the x-axis. And I can see this is not an exact point because it doesn't hit that little tick mark. So this is when we have to remember to do second trace, pick 5 as an intersection, and hit enter 3 times. There's one of our intersections. It's at 3.83. So to get to the second one over here, I have to move my cursor over there. You can do this, but I don't think this is going to work because you have to be on the actual blue line. So I'm going to do second trace, 5. See, it's still over here. Now I'm going to move my cursor to the left. And I'm just going, oops, I went a little too far. I want to be right by the y, by the x-intercept. That's right there. And now hit enter 3 times. 1, 2, 3. And then our other solution is a negative 7.83. So our solution here, the solution is x equals negative 7.83 and 3.83. Now, the things you can remember using your calculator, you have to have 2 equations. You can do second trace, and then we can do number 5, which is intersection, and then we have to remember enter 3 times to get to that intersection. Okay, so this is how you would use it with your calculator. Now, for factoring, because they might say the word factor, we want it to be in standard form, and we want it to equal to 0. So ax squared plus bx plus c equals 0. This is in standard form. I forgot my x squared, sorry. And what we want is the a to be an invisible 1, which it is. And so when I have an a as an invisible 1, then I can go straight to my x puzzle. And we have to remember the way this is set up. We want factors of c. C was the 18. What the sum of b? B is 11. The 2 numbers on the left and right are your factors, numbers you multiply together. So the factors of 18 are 9 and 2, because 9 times 2 equals 18, and 9 plus 2 equals 11. The times here, sorry. So our factor form is x plus 9 and x plus 2. Okay, this is, I'm going to come down here, sorry. That's the factor form. The solution is, remember, when I want the solution, I have to take it out of this, or basically make each factor equal to 0 and then solve for x. Okay, but hopefully you realize just subtract 9 on both sides. You can do this mentally, or just do the opposite. X equals a negative 9 and a negative 2. That's the solution. All right. Know the difference between factors versus solution. All right, and the last one is quadratic formula. That is this formula up here. The parts you need in the formula are your b, your a, and your c, which is why you want it in standard form, which means we want this equal to 0. So we're going to start off with minus 12x. I'm going to line this up with x. Minus 12x. Excuse me. This cancels out, becomes 0 here. So we have x squared minus 10x minus 16 equals 0. And from here, I can identify the A, that would be 1. The B, that's a negative 10, remember that's a middle term. And our C is a negative 16. We need this to put it into the formula up here. Okay, we need to plug it into the parts in this formula. So when I do that, we're going to start off with the negative B. So we do negative and then do parentheses to plug everything in. So this is a negative. Inside that is 10. Then we do plus or minus. Then we're doing our square root. Underneath the square root is B squared minus 4AC. So parentheses negative 10 squared minus 4 times A, which was the 1, times C, which is the negative 16, all over 2A, which is 2 parentheses 1. All right, so when we simplify this and put this in the calculator, we start off with just putting what we have underneath the radical in the calculator to get that simplified for that root form, okay? So to go to that calculator, we have to hit second quit. That should have turned that off. So I'm going to do parentheses, negative 10, close the parentheses, square it. Then I'm going to have minus 4, parentheses 1, then another parentheses, negative 16. And then we're going to hit enter, and we get 164. So this is, excuse me, this is what remains underneath the radical. Okay, so when I write it out, I look first left to right. The first thing I see right here, negative and negative. So this turns into a positive 10. Excuse me. We have a plus or minus, so I'm going to do 1 with plus. Square root of 164 all over 2. And then I'm going to do another one with minus. And minus the square root of 164 all over 2. And this will give us our decimal answers here. So I'm going to go to my calculator. I can basically just use my fraction key, my fraction bar, to plug this in. So that's what you kind of saw before. So you do alpha x, we type in our 10, we do plus. With the square root, you have the second x squared, and then you have to do 164 on top, underneath, excuse me, and then underneath, at the bottom, we put in a 2, we hit enter, and we get the decimal answer. We're going to do the same thing for subtraction. So alpha x, 10 minus second x squared to get the square root button symbol, 164, and then 2, hit enter. And so here's our two answers, 11.403 and a negative 1.403. Oh, 3, sorry, there should be a 3. All right, and so that takes care of your quadratics. Oh, there's one other thing I want to show you on your decimals calculator. Let me do that real quick. Hold on. Okay, so let's say you want to do computation, because most of the time the graphing calculator is going to pop up is the graphing. You can see graph, but you can still type computations here. So like, remember we had on the last one, 10 plus the root 64 divided by 2. So you do the 10. Let me change this, because we just need a slash. Let me get by the keyboard. I'm going to do, where's it at? There it is, slash, to get my fraction, okay? All right, now I need to get my cursor back up to the top, and we're going to say plus, and then right here is the square root, 164, and then I'm going to come down and put a 2, and right there is already giving me the decimal answer right there. So you can put computation here as well. Like if I wanted to do, like maybe you needed to simplify. Let's try it. And then we needed to do, that's not what I want. I want the slash, I want the regular keyboard. Sorry, to get my fraction there. Let's say I was gonna do, see, it gives me the decimal equivalent. The only thing I don't know how to do is to convert that back to, there it is, there it is. You hit that button right there to the fraction. So if I click that, if I click this, it gives me the decimal right there. And then if I click that button right there, it gives me the fraction. Okay, so there it is. That's what I just wanted to make sure you have all that. All right, thanks guys.